Yep. So up next is John Gruener talking about lunar base planning. Are you able to speak, John?
Yeah, apparently my video is not going to work, but that's okay.
Oh, there you go.
All right. So, Jim just talked about institutional amnesia. Oh, there I am. And I think that's what Amy asked me to talk about, to remind everybody that this lunar based planning has been going on for a long time. There's tons of documents and reports out there about lunar bases, just like we have in the lunar science community, right? Over 50 years worth of science papers and books and journals all about the moon. I first got into this, I chuckle, it's my first day on the job, but my uncle worked here at the Manned Spacecraft Center during Apollo in the big vacuum chambers, thermal vacuum chambers, chambers A and chamber B, that they tested the Apollo spacecraft in. And I loved space back then. I loved that, I had an uncle I could go and see what he was doing. And of course, at Christmas time, I wanted space toys and I wanted the big lunar base. Uh, I quickly learned we didn't have enough money for the big lunar base, so I had to settle for sortie equipment, right? But I had fun playing with my Major Matt Armstrong toys, and you can look at those on eBay. But even in the public world, this idea of lunar base wasn't restricted to the technical world. All right, next slide. So we're going to go through. So is Ricky going to advance my slides? Because
No, I'm just having a issue. I got into annotation mode somehow.
okay. Well, so we're going to go through about 70 years worth of lunar base planning in the next 15 minutes. My little fun picture there, from the mid 60s during the build up to Apollo, happened after the blueprint that started in the 1950s, at least here in the States. And my talk here is going to focus on what we've done here in the United States. Of course, around the world, other people have talked about this as well. And of course, Arthur C. Clarke, he's not an American, but man, did he have vision, right? And so this book came out in 1951, and it's a short read. It's a great read. And he had 2 chapters focused on the moon. And in that first chapter, I was just talking about the moon himself and the science as we knew at the time. There was this great quote that really resonated with me, because when I started working on all of this stuff back in the late 80s, I kept asking people, well, why are we going back to the moon? What are we going to do there? Shouldn't we be talking to the people that want to do something there so we can design to those needs? And of course, Chattel did a great job of showing, architecting from the right. So, and this is basically my career in a nutshell, this first quote, where the first half talks about the engineering, which was my first degree. But then I got a planetary science degree because I really was interested in what it is we were going to do there. I'm not going to read all these quotes on chapter 11. Again, this is like 15 pages worth. So it's a really short read. If you want to just focus on the moon. But the first lunar explorers will probably mainly be interested in mineral resources of their new world, and upon these, its future will largely depend. So there you have it. ISRU was, they didn't know that acronym ISRU, but resource utilization was talked about way back when. And then one quote I didn't have room for on this slide, kind of timely. He said, the idea of a fully developed lunar base may seem somewhat impressive, not to say fantastic, but we are now looking 50 or 100 years beyond the first landings. Well, guess where we are? We just finished the 50-year parade of all the Apollo events. We're coming up on the 50th anniversary of the last Luna missions. And so we're kind of in Arthur C. Clarke's target zone for when lunar bases might happen. All right, next slide. So he wasn't the only one. Many people, I believe, probably saw these articles in Collier's magazines. There was about 10 of them, all told, spread between the years of 52 and 54. And they went into a lot of engineering details that Arthur C. Clarke did not. I kind of chuckled when Jim talked about geophysics and how important it is. And look at that picture in the middle there. A guy is, shooting off a rocket to make an explosion so they can do geophysical work. On these slides, you'll see little black box or science mentioned. So science is a big part of everything that was being talked about, even in the 1950s. And so, what we're doing today and in all the LSSWs is just a continuation, of 70 years worth of talking about science on the moon. All right, next slide. So we get into the 60s, and of course, everything was focused on the Apollo missions, but there was something called the Apollo Applications Program that was looking further, than just those first few missions, and actually staying longer than I know this one says 2 men, 2 days on basic Apollo, and we went 3 days with the J missions. But there were people already in the 60s thinking about ways to extend our duration on the moon. And guess what? You see a lot of the same stuff you see from Shuttle, right? Where we have mobile pressurized rovers to go along with the unpressurized buggies from Apollo. We actually have a habitat in that far right, the shelter, the bluish area is where people would live inside of this Lisa shelter. So you can see there on the attribute on the bottom where I found these great little drawings that Mark Wade created on the computer to kind of show people what was going on with the Apollo Applications Program. All right, next slide. So after Apollo, things kind of died down, and the moon really wasn't really talked about, right? It was all about the space shuttle, right? And going to a space station someday with the space shuttle. But in the mid 1980s, Wendell Mendel and Mike Duke and others started up this conversation about lunar bases. And this is the era when I was in college getting my aerospace engineering degree. And these conferences, went through all the kind of things that Chattel was just talking about, right? But there were no government approved, US NASA programs to go back to the moon. It was just a lot of talk, right? So next slide. And it wasn't just the conferences. So, I don't know why we publish things in orange, but anything in orange from the 80s is really cool to read. That the geoscience and lunar base is something I looked through a lot and highlighted and dog-eared for my education. But you can see astronomy, ISRU, and then also in this era, there's a ton of information from the American Society of Civil Engineers and the meetings they held every 2 years. As a matter of fact, one is just in the next couple of weeks in Miami. That this thing is continuing. So if you have access to the ASCE, there's so many papers here that talk about the engineering details. Next slide. Now, I said we had no official program. 1989, 20th anniversary Apollo 11, the first President Bush made a big speech about going back to the moon, called it the Space Exploration Initiative. And of course, NASA spun up what we call the 90-day study. This is kind of when I entered my career at NASA. I worked on the 90-day study. I list the 5 science themes there just to emphasize, even back then, people were thinking science and what we might do on the moon as we developed these different approaches. And really, there was one approach in the 90-day study with some variables that kind of adjusted the schedule and some of the technologies, and it had a huge price tag. And people were, they couldn't believe it was going to cost that much money. But this was a 30-year program with the space station, lunar missions culminating in a lunar base, and 3 human missions to Mars. All right. So the price tag was astronomical, according to the press. I didn't think so, but according to the press. So next slide. Oh, so here's just some concepts from the 90-day study, another little report you can find online. I'll give you a reference for that later. But look at the lunar post architecture. If you, in that one picture, you have landing zones, you have habitation zones, you have ISRU zones. This very same thing is happening today with the group that Ruth Ann Lewis is leading, where we're trying to plan for a lunar base, and we use some of these very same terminologies, right? So it's quite funny how history is repeating itself. Next slide. All right. And of course, just like Chesley Bonestell and those artists of the 50s, Pat Rawlings and others, let the public see what it is we were talking about. And you can see our pressurized rovers were not only a big thing in the 50s, 60s, and 70s, but during Space Exploration Initiative. All right, next slide. All right, so because of that big price tag for NASA's 90-day study, there was this outreach program resulting in a synthesis group where they're going to look at some outside experts, relook at the 90-day study, and you can see the 4 alternative architectures that came out. This was the first time I believe that the word architecture was actually used for all this. And waypoints were their tool, I guess, to, how you move through the architectures by, getting to waypoints and satisfying waypoints. And you can see them, all the different ones listed there. So next slide. All right. So Mike Griffin came along, and, even the synthesis group architectures were expensive because they were long-term, multi-decade. So it's expensive. And we always focused on the end and the big picture. But Mike Griffin said, all right, no matter what we do, we have to start off with something. What are those first missions? And so the first lunar outpost concept was created, where we had 4 people living on the moon for 42 days. That's 2 lunar days with a night in the middle. And you can see in the cartoon how it's a common descent stage with a habitat on top of one and the crew vehicle on the other. We worked on 6 different landing sites. You can see the people involved there, the champions for those sites. And then again, all the science that we were putting into site selection for the outpost. And, next slide. I talk about how a lot of, science has been in this from the beginning. One of the key things that I think scientists can do for all these architectures in the past and the future is that site, right? Because if you pick a site that doesn't pan out or doesn't have all the science you were hoping for, then maybe you can't go as far as you did, right? So picking that site is really important. This is a concept of operations that I worked on. It's a white paper at LPI. You can download it. And you kind of see we're on the eastern limb at Mari Smith Eye, so we had Earth Shine that could help us out with our EVAs. Again, you can see all the science payloads that we were going to bring down for that 42-day mission. Next slide. All right. And then it kind of died away, right? The moon kind of died away again, the ebb and flow of lunar exploration, unfortunately. But in 2004, the second President Bush, also gave a speech. This one was called the Vision for the Space Exploration. 3 big goals. We had just had the Columbia accident, so get the shuttle flying again, build a space station, and then return to the moon. And robots were prime in a big document now for one of the first times. Get the robots ahead of the people to help find out things. Jim talked about Viper and how important that's going to be. And Viper's only one mission. There's another paper that talks about how we need a series of Viper-like missions and other missions. The LWIMS group did a report. I was a part of that as well. So you can see this was much like things from the past. A big part of VSE was international participation, but more importantly, commercial participation, right? So how do we get the commercial people in the United States involved? And you can see where that's come from. Now we just had Intuitive Machines landing on the moon. That's a commercial mission. So that talking commercial and vision of space exploration was really important. Next slide. All right. So just like on the first President Bush, well, what do you do at NASA when a president tells you to do something? Well, you conduct a 90-day study. All right. This one was called Exploration Systems Architecture Study, a bunch of different design reformations. I mainly worked on the lunar surface activities and what we would do there. And you can see words like March forward, right? That you've seen throughout and like Jim talked about. And then there are the scientific themes. We hadn't had the scientific context for the exploration of the moon document yet, but people were working on it. And so you can see all those important things that were in that document that heavily influenced what we did during the constellation days. All right, next slide. And this is just kind of a list. I was working in the Lunar Surface System Project Office. This is kind of a list of all the different things we were looking at. Most of the pictures wound up looking like what, or, for the public, wound up what you see on the right there, where it was a fixed habitat, space station type modules, solar arrays pointing sideways because we're at the South Pole. We were already talking South Pole during constellation. Next slide. But by the time Constellation finished, we had a much more international flavor and international participation. We had something called the GPOD, the Global Point of Departure, where we worked with internationals, and the desire for mobility was really strong. So instead of, plopping down at one spot, maybe you could get everything you need for your base on wheels and kind of move the base around for a while before you finally settle on a spot and maybe get off your wheels. The challenge with these mobile architectures is the type of work you want to do for ISRU, the type of work you want to do for biological and physical sciences. Those kind of require being at one place for quite a bit of time. And then if you're using ISU, of course, you got to be where you're making it. So, but this is kind of where we finished up with Constellation before it's canceled. Next slide.
Yep, and John, if you could start wrapping up.
Yep,
Please.
I'm almost done here because this one won't take long. Chattel talked all about that, so I didn't use any of my time on Artemis, but same cartoons as you've seen before: rovers, habitats, spacesuits. Next slide. All right, so here's some common themes across the ages, right? And Jim talked to this too. Surface mobility, that's key, not only for science, but for ISU as well. Science, it's always there. It's always been there as a major activity. Maybe not the primary driver on a lot of these endeavors, but always there as a major activity. The evolution of the base, just like Chattel talked about, right? Eventually, you do need a fixed location, resource utilization, nuclear power, all necessary for these long duration, large scale. And then, of course, the humans, we got to keep in mind, humans can't stand the radiation and that extreme environment. So we got to do everything we can to protect our astronauts, right? And so there's the link to David Crean created this website at LPI during Constellation. It's still there. I think they may still update it, but it's chock full of most of what you just saw today. And finally, my last slide. So remember on the first slide, I was 6 years old. Well, now, 5 years old. Now I'm 63. So it took me, 58 years to where I get to participate on my first lunar mission of exploration. And yeah, ironically, it was still a sortie, right? But we're going back with Artemis to build a base, and hopefully it'll be this time to stay. All right. So thanks.